To start out number 19, let me just remind you what the correlation coefficient R is talking about. I'm just going to draw a coordinate plane. Whoops, that's not what I meant to do. Let me draw a coordinate plane here and another one down here. And for this one, I'm just going to make some data points, right? Okay, you get the idea. Okay, so when the data forms a fairly straight positive line, okay, when it's all fairly close to a positive, then we can say that the R value gets closer and closer to 1. Okay, so if R is equal to 1, that means all the data is right on the line. Okay, and then we also could have a scenario where the data would have a negative correlation, right? Okay, so then we would have a -1. Okay, the idea is -1. Now I'm suspecting these should be crossing through here, but that is not the point of what we're talking about. So what I want you to see is that the correlation coefficient R is never going to be greater than 1. It can't be better than perfect. In other words, if all the data is exactly on the line, that means the R value is 1. Okay? If in the negative correlation, it's all exactly on the line, that means the R value is -1. So it can't be better than perfect, which means that the R values are all going to be between 1 and -1, okay? So R is going to be between -1 and +1, okay? So here's our compound inequality. I hope you can see that pretty quickly. Actually, technically, I think it should be less than or equal to, yeah, okay? But then it also asks us to write it using absolute value symbols, okay? Well, that's actually not so hard because we know that the absolute value of R has to be less than or equal to 1. Absolute value allows us to put, for example, we could put a -1. If we plug the -1 in here, that would still mean it's less than or equal to -1. So this is the way that we would write it with absolute value notation. This is the way we would write it with an inequality symbol. I hope that helps.